Okay, working with square root functions. Square root functions we're going to find are actually just the inverse functions of the y equals x squared. So it is the inverse of the quadratic function. And so that's why one of the things that we want to do is be able to find the inverse of a quadratic function and find the domain of a square root function. So if we just think of the inverse, and if I start off with y equals x squared, step one, you were supposed to write your function in terms of y, which we've done, so y equals x squared. When we were doing inverse functions, that's what I'm looking at here. And then number two, we were supposed to swap my x and my y. And then step three, we were going to go ahead and solve for y. So in order to do that, in order to get rid of the y squared, I would have to find the square root. If I find the square root of one side, I must find the square root of the other. And then that would be the square root of x is going to be equal to y, or let me go ahead and reverse that. Y is going to be the square root of x. And I think number 4 said that we're going to go ahead and replace y with inverse of x equals the square root of x. So that's showing you how we were able to go from the quadratic formula to the square root function, or the quadratic function to the square root function, and show that it was the inverse. And so as we're going to find the inverse, and we're going to use those steps that we just used. Let's see here, number 1. In this case, we're going to go ahead and first thing we want to do is swap the x and y. Then 2, we're going to go ahead and solve for y. And then 3, we'll probably get there in a second. So I'm going to go ahead and looking at this example right here, I have y equals x squared minus 12. So to find the inverse, it's already in form of x and y, so I'm going to go ahead and switch my x and y values. Now continuing to isolate now for y, solving for y, I'm going to do my inverse operations to isolate y. And so I end up having x plus 12 equals y squared. In order to get rid of the y squared, I'm going to go ahead and find the square root of both sides. So y is going to be equal to the square root of x plus 12, or y is equal to the square root of x plus 12. So there's my inverse function. And let's see if we try this other one. Over here we have y is equal to 5x squared plus 10. So again, we'll go ahead and swap our x and y, and this is good practice for finding the inverse function too, which is what we did in section unit 1. 5y squared plus 10. Now, again, we have to subtract 10 from both sides. I'm going to have 5y squared equals x minus 10. Again, to isolate that variable with the y, we need to divide by the coefficient. So y squared is going to be equal to x minus 10 over 5. Find the square root of both sides. So y is going to be equal to the square root of x minus 10 over 5. Let's see here, x minus 10 over 5. I don't think there's really anything else we need to do with that. I think that can be a sufficient inverse function. So again, just following the steps. What is the domain of a square root function? And one thing, remember, the domain is the values of x that you can plug in. And I'm going to tell you that you would say, well, I can plug in any value for x. But when it comes to a square root function, you can't, because there's something that you have to recall about a square root. And we can find the square root of a positive number, right? We can find the square root of a positive number. That's going to be either a negative or a positive number, but it's going to be a real number. But we cannot find the square root of a negative number. I'm sorry. We can find the square root of a negative number, but it's imaginary. It is not a real number. So if it's not a real number, then we can't graph it. Therefore, it doesn't exist on the domain. So understanding that what's inside of the radical can never be negative, otherwise it doesn't exist. So and when I say that, well, let's look. If I turn around and say, well, darn, x is going to be 4, then I am going to have the square root of 4 minus 3, which is the square root of 1, which is 1. Okay, I can actually do that. That seems reasonable. I have x, when x is 4, y is 1. Okay, well, what about when x is 2? Well, when x is 2, we have 2 minus 3, which is going to be the square root of negative 1. That doesn't exist. I can't do that. But let's see here, when x is 3, though, I can get the square root of 3 minus 3, which is going to be 0. So I can have 3 and 0. And then what I'm learning here is when I graph this, it's going to start off at 3 and 0, and then 4 and 1, and the shape is going to do that. That is going to be my graph. And the reason that these terms over here, any of these values of x, that if I were to plug it in, would make it negative. That's why it doesn't exist. It starts at x is 3. So if we look at this other example here, and what is the domain of this function? Well, remember, my domain has to be whatever is going to make that equal to 0. The x value is greater or equal to 0. So I could say, well, shoot, SHUTE 5x minus 5 has got to be greater than 0, because it can't be negative. Greater than or equal to 0. It can be 0, but it can't be negative. So in that case, if I were to say 5x plus 5 plus 5, cross it out, so 5x is going to be greater than or equal to 5, divide both sides by 5, and then x is going to be greater than or equal to 1. So it has to be greater than or equal to 1 in order for this to be a true, to be a real value. So that is the domain. The domain of this function is going to be when x is greater than or equal to 1. And I could plug some values in there to see, what it looks like. But characteristically, when I have a number on the outside of the grouping symbol there, that means it's going to be I'm going to go up 1, and then look something like that. It's going to start there, and that's going to be the domain, because this function does not exist over here, right? Starts existing right here along my x-axis and goes this way. So from x is equal to or greater than 1 is my domain. And then looking at the inverse, to find the inverse of this function, and it's a doozy, really. So what can I do? I need to getting terms of x and y, then I need to interchange my x and y, and then I need to solve for y. So in doing so, I think what I will do is go ahead and do some distribution over here. So I'm going to have 2 times x minus 2 squared is going to be equal to 56 plus 8y. Okay, I just did the distributive property right there. Now I want to go ahead and isolate I want to get this term right here isolated. So what I'm going to do is something a little bit it's an easier way to solve a problem, but you may not have been exposed to it before. instead of, I'm going to divide by 2, because we have to remember that this 2 is being multiplied by that parentheses. So if it's being multiplied, my inverse operation is going to be to divide. So I'm going to divide that by 2 to get rid of that, and it is going to cancel out. But if I divide by 2 on one side, I must also divide by 2 on the other. And when I do that, we have to remember that this becomes a common denominator, and this is going to simplify down to 4y, and this is going to simplify down to 28 over 1. So when I rewrite this, clean it up, it's going to be x minus 2 squared is equal to 28 plus 4y. So we have almost there. We need to isolate, or I guess now we can go ahead and rewrite, interchange our x and y. So I will go ahead and interchange my x and y. So I have y minus 2 squared equals 28 plus 4x. Now solve for y. And in order to get this y by itself, I'm going to have to find the square root. If I find the square root of one side, I must find the square root of the other. And this becomes y minus 2 is equal to the square root of 28 plus 4x. And then add 2 to both sides. Then I have y is going to be equal to 2 plus or minus the square root of 28 plus 4x. And there you go. There's my inverse function of that. Again, it seemed like a big, nasty problem right here, but all I did was just start with step 1 and continue to simplify until I got to isolating the variable I was looking for. And that's the intent here, is just step 1, step 2, step 3. Don't try to do too much in your head. Don't try to do too much in one step. And some people may have, there's another way to do this. Let's say if we started off with just, there's tons of ways to solve an equation as long as you follow the rules. So what I will do here is I can do the distributive property. So I have 56 plus 8y. And now I can go ahead and let's try it this way. Instead of doing the distributive property, why don't I just divide by 8? And then I would have, this would cancel out, and I would have 7 plus y is equal to, and then my 2 over 8 would cancel out, and that would be 4. So I'm going to have x minus 2 squared over 4 equals 7 plus y. I can go ahead and do the square root of both sides, and that is going to be x minus 2 over 2 is equal to the square root of 7 plus y. I'm going to go ahead and multiply by 2, and that's going to cancel, become 1, so x minus 2 is equal to the 2 times the square root of 7 plus y. Well, you did forget. I did forget to go ahead and swap my y and my x. And then I can go ahead and add 2 to both sides. And then y is going to be equal to 2 plus or minus 2 square root of 7 plus x. So that's another way. These are the same answers, just written in a different form. So just keep in mind that there's multiple ways to to solve an equation. It's just a matter of making sure that you're using numbers and using the rules that we're supposed to use to solve equations. And then finally, just to recap, square root functions are the inverse of your quadratic equation. And when you do your transformations, you have your vertex form of a quadratic equation is a x minus h squared plus k. This stretches, shrinks. H moves right and left, k moves up and down. Well, the characteristics here for a square root function follow the same rules. Instead of the square root of x, we have y equals a times the square root of x minus h plus k. These all do the same thing to the translations of the parent function. So just keep in mind there's a lot of overlapping rules out there. And you think, wow, they do, with enough practice, they do look the same and they do the same characteristic changes and act the same way. So we'll recap this in a little bit.